All right, Ben leaves at 8 o'clock, heading east. Let me get my pencil back. So Ben leaves at 8 o'clock, heading east. And Al left someplace at 11 o'clock, heading west. Okay? And at a particular time later that day, dispatcher retrieves data. The data showed that at that time, Al had averaged 40 miles per hour. This column here is the rate, 40 miles per hour. And Ben had averaged 20 miles per hour. And it showed that Al and Ben had driven a combined total of 240 miles. So from this point here to this point would be 240 miles. So this first column is D for distance, R for rate, and T for time. And distance equals rate times time. And let's somehow try to come up with an equation with that 240 miles. So if Ben is on the road T hours, how long is Al on the road before they make this measurement of 240 miles? Well, he leaves 3 hours later, so his time is T minus 3. So if Ben was on the road for 4 hours, Al would be on the road for 1 hour. Now, the way these distance, rate, time problems work, you always want to fill in 2 columns completely. Leave 1 column blank and then use the formula to fill in the 3rd column. So distance is blank, and we know distance is rate times time. So that would be 20t, and then this will be 40t minus 3. And this is Ben's total distance. Let me change color. That would be, he went 20t miles, and then Al went 40t minus 3 miles. And we know if we add those two together, go and get rid of your parentheses, 40t minus 120, that gives you a total miles of 240. And we're trying to figure out at what time did the dispatcher retrieve data from the vehicle tracking system. Okay. All right. So let me see. What does it say? Let me see. At a particular time later that day, the dispatcher retrieved data from... Okay. All right. So let's solve this equation for t. So it's going to be 60t equals, add 120 to both sides and get 360. And t will be 6. So what is 6 hours after 8 a.m.? Because 8 a.m. is when he leaves. It's when Ben leaves. So 8, 9, 10, 11, 12, 1, 2 o'clock. And that will be answer B.